Well, let's go ahead and get it going today, everybody. Welcome to LLM Ops Cohort 1, Week 4. Today, we're talking visibility, and we're going to talk about some of the tools that we need to essentially do the equivalent of what you may have heard about in ML Ops or with ML, talking about monitoring, talking about that last layer once it's in production. How are we going to look at things? How are we going to figure out how to make them better? That's what today's all about. Welcome to everybody joining us live. Welcome to everybody joining us asynchronously through the interwebs. We are going to cover the final pieces of content today. And I just want to say, first off, thank you to everybody. Everybody that's in this room, everybody that's been joining us consistently, everybody that's always there to provide the feedback that is super critical, that helps us really take to the next level. Thank you, everybody. I shared a little bit about this today. We've been rapidly evolving the curriculum in real time, as you all know, and we're really excited for the version 2 of the curriculum coming in cohort 2 in just a few weeks. And it really wouldn't have been possible without all of your feedback, really dialing in exactly what people need to know, what they don't need to know, what order and sequences should be taught in. So definitely appreciate all of that and would really encourage everybody to check that out when they get a chance. If you have more feedback, let us know. But, this is really has been a team effort, and just, shout out to everybody that, continues to keep it coming. We will also be, I'm very excited about this. We realized, a lot of you guys that you want more stuff. You want to talk about fine tuning, and you want to go deep on instruction tuning, and you want to talk about RLHF, and you want to go deep on all these classical sort of fundamental LLM aspects associated with benchmarking and architectures. And we believe that there's a real market for this. We believe that there's real value in this, and we believe that this is something that people are going to be really excited about. So, this isn't sort of official yet, but I have posted in the Discord channel about the new curriculum that we're putting together for the next class, which is going to be LLM engineering. And so for those of you that maybe, you might be interested in this, people might be interested in this, definitely jump in and give us some feedback on this curriculum as we get it up and rolling. It's going to be a similar process of figuring out what to do, what not to do, and how to deliver the most possible value to students that are coming in and joining us on the teaching and learning LLM journey. So big shout out to Juan and Pano for getting after it, giving me some feedback already. We'll see how it keeps going from there. All right, so with that, we did look at your homework from week 2, and a couple of things I'm seeing. We did sort of address a lot of the things people brought up in terms of lessons not yet learned. You wanted to hear more about eval. You wanted to hear more about, how do we really dial in the quality and figure out what to expect and how exactly is scoring happening and all these sort of detailed eval questions. And I think these are great questions. I think if we can, we might sneak them in a little bit more in the next cohort. But at the end of the day, this is sort of at a level of detail that is going to be hard to sort of teach outside of your particular project. But it's definitely a level of detail that we super encourage you guys to go into, especially this week as we're finishing up and you're getting that final project put together, which we'll talk about today. These are the right questions to be asking, and we'll try to give you the set of all possible right questions to be asking to take your simple RAG system to the next level. Also, the last piece is maybe we could do a little bit more on the Hugging Face intro side. Maybe we could do a little bit more on that support side. But, other than that, I want to kind of pass it off to Chris, who did go through in detail all the homeworks this week himself, to talk a little bit about what he saw that you guys did well, what you guys struggled with, and what he took away from looking through all your work.
Yeah, thanks, Greg. I mean, basically, it's I would say things that would be expected. So a lot of people were kind of had questions surrounding the actual, how do we scale this up? How do we modify this to handle our scaling needs? And then subsequently, how do we, implement this in a way that, can scale horizontally? It's definitely something that we hoped to cover a little bit better with the SageMaker resources and the AWS resources. But overall, I would say feedback for this is I guess Juan said it best, you know, just to steal what Juan said in terms of what I saw. You don't need to have the scaling covered now. You need to be able to have an application that runs now. And in terms of the code that I saw, that was mostly fine. Some people I think struggled with the access to the specific model, so GPT 3.5 versus GPT 4. You can definitely, you can use GPT 4, but if you don't have access, it's perfectly fine to substitute in GPT 3.5 Turbo. I think the idea that you need to use GPT 4 is kind of overrated. And so I saw a lot of that in the actual notebooks. But yeah, I mean, ultimately, things I would focus on are understanding kind of what we're trying to do versus what specific, example we're using. So in the case of the submissions, like the notebooks were fine. The actual deployments that I looked at were totally fine. But I think understanding what we're trying to do, what I would like to see is some documentation or diagramming in order to express your understanding of these systems. I think that would probably be the easiest way to communicate them, and that's where I'll leave that feedback. But ultimately, a good job. I think the two major things are, number one, GPT-4 access versus GPT 3.5 Turbo. I think one of the best signs that you're kind of ready to rock is, we're always going to hit these hurdles whenever we're in production, and just coming up with a clever solution is kind of the piece that I say was I would like to have seen expressed in terms of the assignments.
Cool. Yeah, awesome. Well, we'll keep the feedback coming as best we can. We know we've got just a few more days, and so we'll give you some feedback on week 3 on Thursday, and hopefully that gets you some good stuff from there. So what I want to do is I want to revisit the big idea of RAG in diagram form, and perhaps we can do a better job prompting you guys to please include a diagram or draw up a diagram and napkin sketch it and share it with us. But this is largely taken from a recent event that we did. So if you saw it, bear with us, but I've sort of generalized it. And, we want to kind of consider the core components of a RAG system now. And we should be able to look at this and feel very, very comfortable with the entire thing. We have our input query, and that thing's going directly into the embedding model. We're turning our query into a vector so that we can compare it against interesting things in the vector database that are similar to our query. The user query is going to be augmented. That's the purpose of the augmentation in retrieval augmented generation. So we're taking the query and we're adding context to it. We're doing that by first writing the query, converting it to a vector, and then we're going to search for similarity to that vector within our vector database. So to this point, we have not actually used the big LLM. Okay, really important to note this. So the big LLM comes in, the chat model LLM, let's say, comes in when we're ready to provide that official prompt with context. And the prompt gets the context by, as we take it to the next slide, we're going to actually get that returned similarity. We have the stuff, the documents in a natural language processing sense are now returned from the vector database. We're now providing those resources and that additional context from each of those specific source documents to our prompt, and then we're providing that prompt plus context, now augmented, to the chat model. Once we do that, we can get our final answer. Let's say our chat models, in this case, Llama 2, because obviously, yeah, that's what everybody wants. So this is the retrieval augmented generation system in a nutshell. And this is sort of where we need to be thinking about sort of, this is the basic RAG system. Deepak, what's up?
Yeah, Greg, one question I have is for the embedding model. You know, I haven't seen like how you can change different models there, right? So maybe question more for Chris. Like, you know, API wise, like if you want to change the embedding model, you know, some of this is done by the vector database, whatever, right, facade itself, right, underneath, right, where it is done and how can you change it, Chris?
Yeah, I mean, basically, we have a number of different ways we can change it, but the easiest way is where we're setting up our embeddings model through LangChain. So that's a step that usually looks like, you know, from langchain.embeddings. We're going to just choose whichever embeddings model we want. You can even use like custom embeddings models, but the idea is that you can use whatever embeddings you want. The way that we do that is through the embeddings module in LangChain. When we set up then our vector stores or vector database, whatever you're using, you can keep that context and reference that embeddings model. So, you know, say for instance, you want to use a Hugging Face embeddings model, right? So you can use something from the hub. You can use something from the, you know, Cohere, whoever you want. But the idea is that we're going to do that in this step where we, you know, set up our embeddings model. So like, for instance, this is our sentence transformer embeddings that we're gonna be leveraging, right? This is the where the magic happens, as it were. And you can select whatever embedding model you want, as long as you keep it consistent in your vector store, and anything else that's going to interact with your vector store, you're good to go. So in production, you would top level this and have a config that would point to your embeddings package.
Yeah. And, you know, and I think the big idea to think about is that each of these components that has a piece on this diagram is a block that you can switch out. So you can literally take the embedding model, switch it for a different one, take the vector database, switch it for a different one. You can, and when we talk about evaluation, we're really now connecting even the input and the output in more of a closed loop. And we don't have that diagram for you yet, but we definitely will be building it soon. But more specifically, when we want to take our systems to the next level, we can sort of go back to the beginning here, and we can say, okay, we're querying, we have some input query, and then we're going to create some sort of vector from it. That's going to depend on the embedding model. So maybe I need to think about what is the best embedding model. Then I'm going to actually do a similarity search to find nearest neighbors within my vector database. Well, what similarity search am I using? What similarity metric am I using? How did I create my vector database? What vector database provider am I using? What are the embeddings like that I used to take my data and put it into the vector database? Right? There are questions at each step along the way. Okay, what happens when I'm returning documents and then I'm actually augmenting the context? Well, my retriever is going to define the way that I'm actually returning this additional context to the prompt. So maybe I want to think about some more detailed retriever methods. Maybe I want to think about, you know, not just using like stuff all the context in the prompt. Maybe I want to use, you know, more of a refined method. You know, in LangChain, there's sort of a map reduce, there's a map re-rank, there's different methods there. Or maybe I want to even make my retriever like pretty crazy. Maybe I want to make it, you know, more of a hybrid setup where I'm using, you know, different types of retrieval methods. And, if I want to get really crazy, maybe I want to add llama index here to create my index and do my retrieval and use LangChain to glue the rest together, right? Because I like the way llama index does stuff. And, you can obviously replace the chat model however you want. But at each step of the way, there's going to be things. And how am I chunking my data in the first place, right? At each step of the way, there's things that you can turn and tune and try to fix and make your whole system operate better. You, of course, have to know what you're aiming at and how you're going to sort of measure if you twist and tune things, how you're going to measure whether or not you did better or worse. But that's the big idea of evaluation, and that's the big idea of taking your RAG to the next level. And once it's in production, that's all you're going to do. And if you have a team of data scientists, that's all they're going to do. It's going to be somebody's job to like tune all the knobs on this thing all the time. And it might be yours. It might be your job to do that. That might be the job you want. But it also might be the job to figure out how to just put the glue of everything, in place and oversee what systems are being chosen to take which to the next level. So what we're saying is, this is all Lego blocks. All right, it's all Legos. And there's all different ways to take these simple systems to the next level and turn it into your custom RAG and be doing some real LLM ops. Because everybody does basic RAG. I mean, who cares about that at this point, right? It's like, how are you going to take your RAG to the next level? And there's some easy ways, right? Well, you can like act like you really care about similarity metrics or, chroma versus face or whatever it is. But you can also get real creative with your evaluation or hybrid approaches to your retrieval or custom indices. Or, as we're going to talk about today, and we saw with embeddings, you can do some caching. And that's probably a good idea. And once you have this whole system together, it's important to be able to look inside of it. It's important to be able to see what's going on inside of it to help you decide how to take these builds to the next level. And that's where tools like we're going to talk about today come in. For instance, WandB prompts, WandB, aka weights and biases. If you know, then you should call it WandB. If you're just a noob, you can call it weights and biases. So, just so you guys know, like, that's what you should do. And like Sarah, heads up when we're at the conferences, let's say WandB to people so we sound like we know. And so this tool is called prompts. Okay. What is it? Well, it's a suite of LLM ops tools. Look at that. Boom. I feel like we're in the right place. It's all about visualizing, inspecting, looking at the execution flow, looking at the ins and outs, and doing it all securely, because that's what all enterprise customers want. To manage those prompts, manage the configs, manage everything throughout the life cycle of your LLM product that you're operating in production, right? And so WandB prompts, it breaks down into a couple different things that are all based on WandB trace. This is sort of the main tool we're going to look at today. And trace is really made up of three parts: the trace table, the trace timeline, and the model architecture. The trace table just gives you an overview of the IO of a particular chain. Not that super interesting. Trace timeline has a nice color-coded display. So that's very nice. It's very nice. It displays execution flow of the chain according to the different types of components in the chain. And then the model architecture is talking about the structure and parameters used to initialize each component of the chain. Okay, so let's take a closer look at this color-coded coolness here on the execution flow. This is what we're going to play with today. This is called the trace timeline, and this shows you the execution flow of your LLM chained application. So we see here, agent executor, LLM chain, OpenAI chat, feeling pretty good about what I know about these things right now, right? Feeling pretty good about like my level of ability to be on this layer of abstraction. And so you can kind of imagine that this kind of gives you the overall thing, and then you can click in. This is also really nice, for instance, if you get an error, right? Uh-oh, ruh-roh, something goes wrong. What am I going to do? Well, you can check it out in the trace timeline, and you can get, hey, look what happened. We got error, got to address it, some kind of issue. We can see it, we can visualize it, we can inspect it. This is that visibility that we need into the chain, right? That's what it's all about. Can I see what's going on? Of course, I could see this in code before, but this is so much nicer. My little GUI based thing. So I don't even need to be a developer to do this. I can just kind of like have my analyst people do this kind of thing. It's great. And so, you know, when you take it to the next level, we can look at the structure, this model architecture piece. And this is sort of a really nice, you know, we're kind of, again, we're looking at code in a nice GUI based form. It's very nice. Agent scratch pad, we see model temperature, GPT-4. We're seeing all of this stuff that we're pretty comfortable with at this point. And so we're seeing the thing and we're seeing the parameters within the thing. So it's very nice. It allows, especially if you're going to show this to, you know, your boss or your team, you're like, hey, look how easy it is, blah, blah, blah. And you can show each step of the chain. All right. So this is the big idea with WandB. And what we're going to do is we're going to take our beloved archive agent, okay, and we're going to learn about some stuff that we love learning about, and namely related to LLM ops. And we're also going to combine this idea of visibility, okay, which is separate and distinct from this idea of a prompt cache. This idea of visibility is not that crazy. It's just, can I see it? Can I see what's going on? You know, when I ask my archive agent, what is LLM ops? Can I like see it? You know, if I have an error in the chain, can I see it? So if I know something goes wrong, can I go in, can I see it? This is less about, can I detect stuff that I don't know is wrong yet? That's more on the monitoring and observability front versus visibility. So we're not really seeing very mature observability LLM ops tools today, although expect those in the future. And, you know, sort of the things that are monitoring specific aspects of your chain, and each time they see some sort of swing, then it'll be like, oh, you know, sending you an alert, sending Raul, the director of engineering, an alert about, oh man, something went wrong, you know, because you automated part of your team, right? But your team has to do this with visibility tools now. This is a human endeavor to figure out what the hell's going on wrong with LLM products. It's not an automated machine endeavor yet. So that's visibility. And that's all we can really do today. That's all we can really worry about doing today. But that's not prompt caching, although we can see how prompt caching works with visibility tools, and that's what we will see. There are lots of tools for prompt caches. Everybody wants to make their own cache. Am I right? I mean, cache is king, right? You know, it's like everybody, I mean, the thing is about caches, and we've talked about this a lot before, they actually can save you money. And that's the point of using them, is especially if you have massive amounts of data, caches are going to save you money. Now you can build your own, like we were nerding out with this one guy yesterday talking about building his own vector stores as caches. You can sort of build a second vector store of prompts and use that as a cache. But you can also just use these cache tools. And we're going to show you how to use a couple of them today. We talked about Redis before. Obviously, LangChain has a cache tool embedded. And, you know, there's another one called GPT cache that we'll talk a little bit about as Chris gets into the code here. But the big idea, right, is if you've already prompted something before and you already RAG searched it, don't go RAG searching it again. It's like, that's just a waste of your compute. Don't do that. All right. Just keep it cached. Right. Put it in the cache. All right. So what we're going to do is we're going to see how we can use visibility, how we can leverage these visibility tools, how we can leverage caching tools, and how we can use tracing and caching, and then actually trace a cache. All right, that's what we're gonna do. And you know who's gonna present it. So over to you, Chris.
Hello. Yes, I will be presenting this. So the idea is fairly straightforward. We're going to look at some examples of how we can cache our prompts, as well as how we can add visibility to our application. So we're going to go ahead and look at the notebook here. Here we go. And you'll notice that there's a couple things that we're doing. Number one, we're looking at these, fairly straightforward environment settings. And this is one of the best parts of all of these tools, especially as we're working right now. These are all handled through, I'm just going to go to weights and biases here. These are all done through like simple environment handling, right? So this does limit the kind of power that we have, but still we have the ability to do a lot of awesome things. So you'll notice that we're setting this to true. We could basically get away with just this and add fairly decent visibility to our application. But we want to add the project so we can keep track, and then our notebook name to make sure that we know what notebook we're working out of. This is just, highlighting that there are some practices you can use to kind of specify where your information is flowing from and to. We will need an OpenAI key, and we will need our weights and biases key. Getting your weights and biases key is very straightforward. We just go to our user settings and weights and biases, and we scroll to what's literally called the danger zone, and then we create a new key. So easy enough. This is all free, does not cost anything. Next, we're just going to set up a simple tool, and the tool we're going to use is, of course, the archive tool. It's, it makes the most sense. That's what we've been doing, and it lets us look at a chain that includes an agent. So it's up to you to set up the actual code here. But once you have, once you've run this kind of test query, you can go ahead and look at weights and biases. And we're just going to go to our home screen, and we're going to go to our LangChain testing environment, and we're going to see what we have set up. The idea here is that when we ask this query, what is QLoRa, we get this kind of table, and this table lets us see all kinds of fun things about our chain. So the easiest thing to do at the start is just click this kind of, full screen button, and you can see that we have our agent executor. We can see its runtime, and we can see metadata about the agent executor, including how many child spans it initiated, how long it took to run, the status, what kind it is, the inputs and outputs. And then we can zoom into the sub chains or the constituent chains, including the APIs that we're using to actually get the information, right? So we can see our LLM chain, which is our archive tool, is, we have exactly what this is. We have the prefix, we have the so we have the LLM prefix, we have the observation prefix. This is kind of like the affix, right? This is what determines what our actual agent executor is going to do. The idea here is we're going to be able to see exactly what got sent to our endpoint and exactly the response that we received. And we can look in as close, like as granular as our GPT calls. And, we can see the token usage. We can see the specific model we used. We can see the parameters we used to actually invoke this endpoint. So looking for things like these stop token sequences, seeing if we set the temperature and if we did what it was set to. The idea is that, when we're looking through our trace, right, we see the agent executor enters this archive tool, and the archive tool needs to go to chat OpenAI because it doesn't know what this is. right? So we ask it what QLORA is. It doesn't know what it is. And so we're able to then send that again to the model in order to get a response. But we can see this kind of exact flow of how we go through, right? We have numbered, so it goes to the agent executor, which goes to the LLM chain. The LLM chain determines that they don't know what QLORA is, so we go to the chat OpenAI chain. The chat OpenAI chain knows to call the archive tool, so we call it. The actual information that it retrieves is based on the search from archive, which we send with context to our main chat OpenAI in this step, which gets us our result, and then we're able to see the output in our agent executor. All of this information is given to us. And what we did, to remind you, was we set this environment variable to true. So this is an incredibly high leverage activity, right? We're getting so much information for very little cost. We have the ability to everything that we need. We can export these as CSVs, so we can do that lovely data science that we want to do on these responses. We can collate them into a evaluation framework to see if our RAG system is up to snuff, as it were. We can also see the architecture. Now, basically what this is showing us is what steps or flow our actual application has. I'm going to zoom it just a little bit so we can kind of try to fit this all into the same screen. But the idea here is that we have the whole architecture. So we have our executor on top with our LLM chain. Our LLM chain has these few components, right? So we have our actual LLMs, which is our chat OpenAI, which is based on the LLM class. We have a prompt template. You can see the prompt template. If we want to look at it in full, we can look at it here and get the full, go back to model architecture here. We can look at the full model prompt. So this is the question, the input, the question you want to answer, thought. So this is our scratch, like our agent's thought process, right? We can see as well the tools that it's going to use. We can see basically everything. And what makes this so powerful is we have the ability, because we have line of sight, we have the ability to go into our application and modify or change things. And that's what's going to let us use this tool to improve our application. Most importantly, though, it's going to let us see much more detailed information about what we're trying to do and how the information flows through our application. So let's go back to the notebook. We can see, we set up the simple archive application. We can see all the output. That's great. And now let's talk a little bit about prompt caching. Prompt caching itself is very straightforward. We want to cache our prompts. So what that means is we want to keep track of and organize all of our incoming prompts as well as their resultant outputs or responses, so that if our users ask the same question twice, we don't have to hit the LLM again. This is an extension of embedding caches. We can use both in concert or one or the other. The idea here is that we kind of put in a system that interrupts the flow of our application if we've already seen this prompt. Now, there's a number of different prompts you can use. So we can use the Redis cache, which has, some attributes that make it very, very desirable. And then a specific con that makes it not desirable, which is that it doesn't have a chat model implementation. So this is great for usage in, say, downstream tools. We also have the in-memory cache. The in-memory cache is really, really good for what it should do, and it works with all of the LangChain tools out of the box. So you're not going to run into, compatibility issues. But the idea is that, the kind of cache you choose is important. It does matter, but it comes down to your application-specific needs. In this case, we're just going to implement the in-memory cache because it's straightforward and it does exactly what we want. And we have the, once you implement it, that's, again, it's a one-liner and it's implemented. That's it. There's no more steps. If you're going to use, say, the Redis cache, then there are a few more steps. You'll have to make sure that you point it at your Redis instance and that your Redis instance if you're leveraging, say, semantic similarity, has Redis stack, which is their Redis search, REDI search, and so that you can use it as a vector database. But the essential idea here is we have a number of different tools for a number of different applications. But the in-memory cache we're using today is based off of exact search. Exact search is just what it says. If it sees the same prompt twice, instead of getting the LLM to answer the question the second time, it'll use the cache. Boom. You also have the ability to toggle the cache on and off depending on specific tooling. One of the reasons you might want to do that is if you, say, have a dynamic source, you don't want to use the information that you used from last time, so you would exclude that from your cache. You can just set the cache equal to false. So it's very straightforward to do that. But let's look at why this is good and why we care. Well, we have obviously our token usage from the weights and biases call, right? So if we look at this number 7 here, we can see when we go to our chat OpenAI that we used 1,087 tokens. We also used 234 tokens to decide which tool to use. So we're using upwards of 1,300 tokens. That's a lot, right? Yes, it's not free, but it is there, and over the course of 1,000 calls, 1,000 tokens suddenly starts to matter, right? You'll also notice that it took 8 seconds, which is, quite a long time. But using our cache, it takes 0.3 seconds, which is no amount of time. And you'll notice it used 0 tokens, which is a great number of tokens to use. And we can see in our weights and biases trace that, it goes to the agent executor and then it returns the response. And that's it. There's no other step. And this is the power of the cache, right? This is the cost savings that you can extend to your company if you're not using a cache, just by including the one-liner that you'll write today is absolutely incredible. And so that's the idea. That's what we're doing. That's how we can offer visibility through the use of weights and biases prompts, as well as, of course, how we can add a cache. You could use Amazon Elasticache for Redis if you're in the AWS ecosystem. You can run Redis on a toaster, so as long as you have the right code to set it up and then run it somewhere and make sure that you have a connection to your Redis system, then you're good to go. The one thing I would point out, if you're specifically looking to do semantic similarity caching, is that you do need to make sure you have Redis stack, which is easily installable on all platforms. But you do need that because you need to be able to extend Redis to a vector DB for non-AWS solutions. So there you go.
All right. We are going to go to breakout rooms next and let you guys play around with this a little bit. One of the things I wanted to do is I wanted to go ahead and just ask if you have a preferred breakout room pair programming partner that you really enjoyed working with. Let us know in the chat and we'll tee it up. Or if you have somebody that you're working with on your project or whatever the case may be. Now, if you know you like working with somebody, but you haven't like verified it with them, and like maybe you haven't like agreed to go out like that yet, it's okay. Just smash their name in the chat and we'll put you with them. No problem. We got some feedback that I think is valuable, that it really matters who you're paired with, and we just want to make these as useful as possible to you guys. So if you have an opinion, let us know and we'll tee you up. Froze up. Yep. Okay. All right. All right. I'm not seeing anything. Not even here. All right. Well, we're going to open them up for 25 minutes. There's kind of a lot to get through with the visibility and also with the caching. We think it's important that you try to get through this as best as possible, because we kind of really want to focus the rest of the time that you have after our really sweet demo coming up that we can't quite give you hands-on access to, but we know you're going to love. We want to spend the rest of the time of today's session after the super sweet demo, and also the community build session tomorrow, kind of focused on projects and focused on building out your projects as best you can. So see how far you can get in this 25 minutes. And, you know, we'll come around, we'll bounce around, we'll try to find you. And we will, we'll make sure that we are paired appropriately. All right, thanks everybody. We'll see you back in 25. Hey, welcome back. What do we got? Thumbs up? We got thumbs down. How are we feeling? Good? Cool. Yeah, okay. A little bit of this. Yeah, sick. Okay. That's awesome. All right. Anybody have any particularly interesting lessons learned to share? Anybody thought anything was cool?
I was just surprised how easy it was to get like to get the tracing and the visibility into all the chains of calls. Like, you know, it was exactly what I was looking for. That was cool.
Oh man, Josh was about to go work for WandB. Nice.
I got curious what handle underline parsing underline errors. If you set to false, what it does.
So if you set it to false, whenever you have a parsing error, it will just it'll populate as an error. When you set it to true, what it's doing is it's basically just going to retry. So it's not really doing anything, you know, exciting, but the handle error parsing, basically when you get the parsing error, try it again. What it is it's the LLM not outputting in exactly the format that LangChain is expecting. In prod, you're going to spend a lot of time building custom validation for outputs. Like this is going to be a step that is just going to be engineering hours. But the basic chain implementation just retries. So
cool. Yeah.
G, do you have a question, G?
No, I'm good. Thank you.
Okay.
Kumar?
Yeah, so for me and Jason, we had two observations. The first was the question is directly going to the agent right now, but imagine there are multiple knowledge stores, let's say multiple Chroma DBs, which store information from different domains. And we ask a question, let's say I'm retiring in 3 years and I want to know my tax implications on retirement. If my existing knowledge base can answer the question, I want to create like a decision matrix where it kicks off 3 different agents that checks the other domains and summarizes the information, bring it back. How do I, like today, if I ask a question, it says I couldn't find the answer. How do I kick off that decision matrix? Is that even possible?
yeah, it's definitely possible. The idea would be that you would create a sequential chain where the first chain is the first part of the application that you discussed. And then the second chain is your agent chain, including all of the relevant, decision points. So, your whatever it is that you want it to be, basically. But that's how I would handle that in the simplest way in LangChain. So a sequential chain that first goes through the the top level process, whatever you want to call it, and then second will be an agent that has the n number of tools, however many you want, that are going to try to get that information. If you don't want it to be an agent and instead you just want it to retrieve from 4 sources and then select and summarize, then I would use the multi-input retrieval chain as the second part of my sequential chain. So the sequence would be first, if we can find the answer, that's good, return it. If not, then we go into this multi-input or multi-source retrieval chain that is hooked up to whatever your information sources are.
Awesome. So there are ways in LangChain to evaluate the response from the first agent, first chain, and then spawn, parallel
Yes.
agents that needed, right? I mean,
Yes.
that's something I wanted to know. Okay.
Yes. Yeah, there are ways, basically, like you can build traditional application flow through LangChain, where based on the result of your first chain, you can decide to either take or not take actions that you express. So you can absolutely build that system. No probs.
But Bonnie,
When I say no probs, I mean, it's more complicated than some of what we've done so far, but it's achievable in a reasonable amount of time, and it doesn't rely on like 100 agents or whatever. So,
Bonnie, what you got?
Yeah, it's regarding the prompt. So I understanding is the agent chain kind of handles the prompt for you. So is there a way you can kind of customize the prompt, or override or do it your own way?
Yes. So in one of the previous weeks, we looked at a method for implementing chains that did involve that flow, where we specify the prefix, we specify I think maybe the agent suffix, right? So you can have as much control as you'd like over the agent's construction, its prompts, and same thing with any of your tool chains, tool descriptions, anything like that. You have full control over it, but it does necessitate the use of the proper agent constructor, as opposed to using the method we use today, which just builds the agent from tools and the LLM. If you wanted to use that method, you'd have to actually put all of your prompt logic in the LLM piece. But I would recommend just using the agent constructor and then passing in the through keyword argument, the suffix, prefix, everything like that. There is an example in the repository that goes through the kind of like full agent construction if you wanted an example.
Yeah, I have a question, which is like, so I see in like the OpenAI output, it says, well, the prompt sets it up saying you should respond with, here are your tools, respond with actions, etc. And so it responds with, I'm not familiar with this action tool, action input, blah, blah. Does it ever happen that LangChain doesn't know how to parse that? Like, does OpenAI ever respond in other ways that are English but not parsable? Like, is that a source of errors in agents?
Yeah. Oh, for sure. Yes. Output parsing is like the most frequent fail case, I would say. It is absolutely the first challenge you'll want to tackle in production. It isn't a like an LLM ops task, though. It's a straight up like string parsing task. What I would say is, as we see the ecosystem, especially for now that we have fine tuning both through OpenAI's GPT-3.5 Turbo, as well as we have the function API for OpenAI, you're going to be able to build these systems to leverage those tools better. So this is whenever we talk about like fine tuning input output, like this is where it can be leveraged to increase your hit rate, where really what we want to do is make sure our LLM answers in a format that LangChain knows it can parse. That's the lowest. I would say that the reason you would most likely fine tune an LLM right now would be to ensure that its outputs match the format that LangChain wants consistently. But other than that, you can just do it like regex style. It is, though, definitely a challenge that is easily circumvented on OpenAI by asking it to try again. So we use handle error parsing equals true, and that's the solution.
Cool. All right, so that's it for the Q&A period. We let it go a little bit long on this particular breakout room because we've got a very special next up after our quick 5-minute break. We know you want it. Everybody wants it. It's that new. What do you know about LangSmith? Well, we're going to learn about everything you need to know today. You're going to see it operating in action because Chris has closed beta access, because of course he does. We couldn't give it to you guys exactly to use, but we're interested in putting a community session together soon where you can. So we're going to see it step by step. Then we're going to talk about Thursday, which is your big project demo day. And we're going to tell you about all the things that we're doing to get you ready to rock and roll over the next 48 hours for that. All right. 5 minutes. Lift up the timer here and take a little break. Come back and we'll see the wizard in action again. Welcome back, everybody. Okay, so we are ready to get started. And we're talking production. We're talking like the production tool. What's it called? You know what it's called? LangSmith. What is LangSmith all about, man?
Oh,
I think Greg froze.
I'm having all sorts of issues. This Dayton, Ohio internet is trash.
Not no T1. Yeah, definitely.
Are we good?
Yeah, we're good.
Yeah, maybe it's because my new cat blowing it, scratching up the cords.
Don't blame it on Tico.
LangChain makes it easy to prototype LLM applications and agents. LangSmith makes it easy to deliver those bad boys to production. This is going to allow us to easily iterate on our prompts, our chains, and much, much more. This is going to allow us, exactly right, Raul. This is going to allow us to build those products that we
Nailed
need,
it.
just like the manufacturers back in the days of the Smith, building those real production level pieces, not those prototypes. What we're going to do is we're going to show you how we can actually build something in LangSmith and then benchmark what we build against something else. This is pretty cool. What we're going to do is we're going to stick with our archive RAG system. We're going to build a GPT-4 archive RAG. We're going to ask it questions like these ones at the bottom. What data type was created in the QLoRa paper? Who authored the QLoRa paper? Blah, blah, blah. Then we're going to create another system, a GPT 3.5 system. And we're going to compare the GPT 3.5 output answers in the archive RAG system to the clearly better GPT-4 output answers in the archive RAG system. Now, that means that GPT-4 is our truth, right? It is the truth. GPT-4 is the truth, okay? Because we have to pretend something is the truth if we're doing evaluation. And once we do that, we can calculate some things with some LangSmith metrics that are built in. We can also make up our own custom evaluation metrics. For instance, in this case, we're going to assess dopeness of answers. You could equally do this with litness, on pointness, anything you'd likeness, you could use and you could quantify in exactly the way we do with our LLM-based dopeness evaluator, okay? And we're going to track the dopeness of the answers relative to one another, and we're going to benchmark them against each other. You guys ready for this? It's going to be pretty dope. Chris, over to you.
Thank you, Greg. Yes. So let's look at the implementation first in our in code. And so we're going to take a peek here while I realize I don't have the correct window open. Very sorry. Boom. Here we go. And you'll notice that this implementation, once I have it open, is very similar to what we have already seen before in terms of the actual desired, ease of use. So I'll share LangSmith notebook. Here we go. And yes, the idea here is straightforward. We have LangSmith. LangSmith is an incredible tool that is put together by the same team that did LangChain. It is obviously deeply integrated with LangChain, though it doesn't need LangChain to be good. It can use any kind of processing of text in and out wrapped correctly. But we're going to be using it with, of course, LangChain. We're going to build the same app that we did in the last session where we have, this archive tool. We're going to set up our LangChain tracing, which is the LangSmith environment variable. We can also
Can you just make it a little bit bigger, please?
Yeah, you bet. Yep. So there you go. You can also set the project, your endpoint, and your API key. That's classic. And then we can set up our client. This is all we really need to do. Everything past this is totally secondary. Done. We're going to first initialize this tool with GPT-4. And we're going to ask it, a simple question. What is QLoRa? And then we're going to ask it a bunch of questions. And we're going to, see what it says. And once it's done, we're going to wait for all tracers to be complete. Tracers is kind of the back end of how the system is working in LangSmith. The idea is that it's going to send all of these traces back to LangChain or LangSmith, and we want to wait for those to be completed. Once we do, we can create a data set, and that data set is based off of the runs that we've done so far. And this is a very powerful pattern because it lets us see how our system is doing by collecting it into a data set, right? So we're basically saying, hey, take everything that we've done so far and then make that a data set. And we'll look in a second how this is going to look in the UI. We're just going through kind of the code implementation. Once we've created our data set, we're going to build a system that we want to kind of, pit against our data set. So here we're going to build the same tool again, the only difference being we're using GPT-3.5 Turbo. And we're going to create this agent factory. All this does is wrap the agent chain in a function. And this is because if you can imagine if you had memory or things like memory in your application, it might change the results. So we want to not have that be true. And then we're going to set up some evaluation metrics. First, though, we're going to implement a custom evaluator, which is going to be our dopeness evaluator. As you can see, this is a very simple implementation, right? It's just going to evaluate dopeness based on what GPT-4 thinks, how dope GPT-4 thinks something is, right? It doesn't necessarily reflect the power of the custom evaluator, but it shows the pattern, right? We need to have an LLM. We need to send it through an eval chain. We need to have a few properties that it can be leveraged during our pipeline for evaluation. And then we have to actually provide some kind of evaluation response, which includes, in this case, a numeric representation of dopeness in percentage. So how percent dope is something. And we're going to be able to do this using this custom class, which is the string evaluator. This can be extended to be very specific and very powerful. So don't think that because we're using the funny example here that this is not an incredibly powerful pattern. And then we just create our evaluation config by setting it with a number of evaluators. These evaluators are basic things like your QA. So did I answer the question compared to the other to the source? The embedding distance from the source. We have relevance, which is a pre-configured labeled criteria. We can do a simple version of what we did above by just passing this criteria and then setting what the criteria is along with what we want it to measure. And then of course we can include our custom evaluator. After that, this code is just running the test. It does so by sending all of these requests out and then collecting the responses in the LangSmith interface, which we will take a peek at now. So I'm going to switch my share to that so we can see how it looks in the actual browser. And we'll go here and we'll hopefully you can see the projects window for LangSmith. And this is the UI. It's very similar to WandB. We have the same kinds of things, right? So we have our projects. This is what we set in our notebook to be projects. So we have our LLM walkthrough with this unique identifier. We have everything else from, exactly what you'd expect from WandB. We have our chain trace. We have our inputs and outputs. We have potential feedback if users have provided feedback. We have relevant metadata. We have the ability to share this. We have the ability to rate it, the ability to add it to a data set. So you can begin to understand that this tool, while seeming fairly simple, can be extended to be extremely powerful. We also have the playground, which is not available for this particular part of our chain. If we look at the chat OpenAI piece, though, we can launch the playground, and the playground is going to be what lets us fiddle around with the prompt. You can see we have our human AI system or function, so we can declare this will happen from time to time. It's in closed beta, but we can prepare which message we want this to be. We can fiddle with the actual parameters that we used. The idea here is this is the same idea as the weights and biases prompts platform, but very deeply integrated with LangChain. And yeah, we have everything that we would ever want. So that's great, but we can filter this. We can look at specific calls. We can monitor different resources based on runs that we're doing over time. So we have here, tokens per LLM call. If in the few, we can track how much tokens we're using. Maybe we do a fine-tuning initiative that's supposed to reduce our number of tokens per call, and we wanted to verify this with data. We can do that here. If we were using streaming endpoints, we can look at that, look at how those operations are happening. But beyond just being awesome that way, we have our data sets and testing. And this is where the kind of real power of the platform comes in my opinion, which is where we can go ahead and look at our actual run that we've done to evaluate our LLM, and we get, our feedback. So this is our basic how it did. We have a 0.5 relevance, 8.3 correctness, 85%. So GPT 3.5 is only 85% as dope as GPT 4. We finally have that that officially measured. We have our cosine distances. It looks like every question was considered fully answered, which is very good. And we can go right into the details of each of these chains and each of these metrics on kind of how we got here. So you'll notice that in our main chain, I'll zoom out just a little bit. I know it makes the text less readable, but just to help show these three different panes, you'll notice that when we look at our projects and we go to our LLM ops, walk through, we look at the feedback, we don't have any feedback, right? But when we go to our testing run and we look at a prompt, we have feedback, which is going to be indicating, the various scores. And we can look at things like the comments. The criteria is fully answered. Does this response fully answered? The criterion is X. We have the actual individual scores of each object. We can look at the object in the actual tagline and look at the string evaluator chain, which is going to be what lets us calculate these tasks. You can also see how it got the score, right? Because we asked it to provide details in our prompt, think through step by step how dope it is, and we get reasons why it might be the score that it is. And this is I know that I'm going fast, we're packing a lot in, but the idea is this platform is insane, right? In terms of visibility. And, later on, you can expect that it can be extended to features that help more with like what you would typically consider observability. But for right now, in terms of visibility, this tool is insane. It stores everything we need. We have the number of tokens. At the end of the day, this tool is the LLM ops feature that I think is going to really elevate your production setup to the next level. We can do all kinds of aggregate statistics on these things. We can do all kinds of, I see a question about user feedback. Yes, we can add user feedback to our prompts to collect and collate how our users feel about our systems. We can add custom monitoring dashboards to track that user feedback so we can see, say we release a new pipeline, or we do a major index change, or any such architecture change, we can see how that impacts our user feedback and use that to make informed and smart decisions about our platform. Ultimately, LangSmith is kind of setting itself up to be like the LLM ops observability platform at some point in the future, observability platform that's going to really kind of take things to the next level. But yeah, for now, it's an incredible tool. I would suggest that you sign up for the closed beta if you can. And if you can get in there and play around, it's just awesome. One thing that is important for businesses off the hop, and I think this is relevant to some questions that we've had in the feedback and everything like that, is how do we know how to track our kind of like expenses, right? Like or ballpark expenses. Well, these kinds of things like total tokens and where we're using those tokens and tokens per call, those give us access to, and give our data scientists access to, really granular metrics that are going to help better understand and predict cost. It is the coolest. LangSmith is yes. Once they get out of closed beta, I think just start using it, plug it right in. It kind of takes LangChain to the next level. So there you go.
There you go. All right. That was pretty dope, Chris. Gotta say, that was good. That was good. All right. So yeah. You know what? That brings us basically to the end of the formal curriculum. So sad. But you know what? We're not done. And in fact, we have a lot left to do. We are in the final hours of the course. And what that means is it's almost go time to get those final projects done. And what we've seen over the past couple of weeks is that we can build incredible things in just a few hours with the boilerplate code that all of you actually have in your GitHub repos right now. So there's a lot of things that we can do. We can build a simple RAG system. We can add first cut optimization. We can add all sorts of interesting things to make our builds truly next level. And we should. And what we're going to do tomorrow is we're going to do this community sesh where Chris was going to show an example of a RAG system with high dopeness, perhaps even high litness as well. But we thought about it and we were like, well, hold on. If everybody's going to be working hard this week, we should be working hard too. So instead, what we're going to do is we're going to extend our community session all the way back to 6 p.m. Eastern. And I'm going to open it up to talk to you about what your project idea is. We know that you can come to this session tomorrow and get your entire thing done because we're going to help. We're going to help by discussing your idea. I'm also going to hold a brief storytelling workshop where I'm going to tell you how to tell a great story while I'm telling a story. It's going to get pretty meta. I'm also going to give you some slides that you can use for your presentation on Thursday. At 7:30, Chris and I are going to do our final project presentation. on a custom rag with high dopeness, and I'm going to say high litness as well. We're going to do high litness as well. We're going to come together to create our final presentation, and we're going to pitch it to you. From 8 to 10, it will simply be a working session for you guys to get some shit done. And we've seen so many times, if you just show up and you're just ready to rock and roll, it's so incredible what you can put together. Juan will be there to support. We'll get some other peer supporters there. And what I'm most excited about is that I'm going to see if I can get 100 people in the room on Thursday to watch your presentations. Okay, that's my personal goal I'm setting out for myself. I want 100 people, and I want some of them to be like ballers that might hire you for that better job, Raul, than you're about to take over in Spain. Okay, like I want to see who I can get into the room who wants to see the latest and greatest in LLM ops talent that exists on the planet right now, just coming out of our cohort 1. That's what I want to try to do. Okay. And I want to see you guys show up and crush it. And we're going to make sure that you do. Because we can't be putting you on stage in front of a couple hundred people or whatever if you're not going to crush it. Sarah would never let me do something like that. Okay. So we're going to be there to support you guys tomorrow. If you have a project that you know the title of and you know your teammates, tell me what it is right now. Throw it in the chat, throw it in Discord, tag us. We're putting the run of show together. If I feel like you're going to be a powerhouse, I might put you at the end. I might put you at the beginning. Bro, yeah, I'm looking at you, guy. Okay, bring it. Pano, I'm looking at you. Bring it. Christos, looking at you. Bring it. So this is what we're going to do tomorrow. I am sorry we didn't announce this earlier, but we just realized, like, we have to do this. We have to do this every cohort because it's the right thing to do. And we're going to make it a true 2 hours of working time, because we've made that mistake with a lot of workshops we've done recently. We did not give people enough working time. We're gonna have as many breakout rooms as you need. We're gonna have as much support as you can handle. Chris is gonna be there to help you debug your code. And so, show up and see what you can build with us. Tomorrow, hackathon, 6 p.m. Eastern, join us. And we're excited to see what you build, ship, and share on Thursday. All right. So with that, I just want to address this one diagram. Pano, you shared this with me, I believe, on Discord not that long ago. This diagram, I saw it and I was like, oh man, first time I saw it, I was like, that's kind of a lot. I was like, but it's a pretty dope diagram. So maybe it's worth figuring out. And if you kind of look at this diagram, this is what A16Z put up. A16Z is like one of the hottest venture capitalist firms in Silicon Valley. And what I want to do is I just kind of want to zoom in on this a little bit. Okay. In the middle here of this LLM ops stack, this is the emerging architecture for LLM stack. Let's just walk through this as we sort of close out the final curriculum here. The orchestration piece, I think we all know pretty well. Remember that time when we started the course and Chris was like, I'm going to show you a Pythonic version of this thing. And you guys were like, what? Yeah, like he started from the ground up and then we built it out. LangChain, Llama Index. Okay, so now you guys are comfortable with that. Of course, you know how to use OpenAI and do the playground stuff. Data pipelines or data pipelines or data pipelines. Okay, Airflow, whatever. Fine. Embedding models, data, right? You can pick embedding models up from Hugging Face. We were talking about with Deepak earlier. Embeddings leaderboard, we're good on that. Vector databases, how are we feeling about that? Pinecone, Chroma, Face, whatever, man. Pick them up, use them. APIs, SERP, what's SERP? SERP is just Google search, right? We already did that. App hosting, Streamlit. Ali Steamship was on here. Can you believe that? Those guys are blown up.
That is
Streamlit
crazy.
is on here, Chainlit doesn't have app hosting yet, but that's sort of that super shareable app that automatically goes up online. Now let's look over here. What's going on? LLM APIs and hosting. Proprietary, okay, OpenAI, Anthropic, and the like. Open API, Hugging Face, obviously we're familiar with that. Good to go. Opinionated cloud. I'm not even really sure what that means, actually. We'll get Legend Wizard's opinion on that in just a second. But we're going to walk through the rest of these here. Cloud provider. Okay, got it. Got them. LLM cache, Redis, GPT cache. We did that. We did it today. We saw Redis one of the first weeks in the community build sesh. We saw the caching today. LL mops here. Look at that. Weights and biases. We got it. I believe that they were doing the research at this VC firm and they literally picked WandB for LLM ops because they were the only website that used the term at the time when they were doing this research. Okay. And then validation. So just to give us full coverage of the world here, Chris, what's your opinion on opinionated cloud and validation? What do we need to know about it before we're done with the curriculum here?
So for I am okay. I'm unmuted. Sorry. Zoom was telling me to unmute, but I am. We're chilling. For the opinionated cloud piece, basically this is your managed services that are going to sit in the stack. They're going to help you create those apps very fast, or you know, allow you to host things, but it's done in a way that's not very you know, extendable or changeable or interactable. So in terms of things like Mosaic or Databricks, really what we're talking about is just they have very specific ways that they want things set up. You don't have a lot of, you know, bells and whistles, but they host things. You know, it's totally fine. It works very well. Like especially Dbricks, obviously, is it's very opinionated, but it can do everything that you need it to do, so it doesn't super matter. But I would say when you're getting started, those services are usually very cheap, and they usually use kind of, you know, they're a great starting place if you're not ready to make the full leap to something like your AWS, because they take a lot of that decision making out of your hands and quote unquote just work. If you're choosing a larger opinionated cloud service, if you're choosing a smaller one, buyer beware. In terms of guardrails, so validation, basically, validation is an important step. It's still very immature. It's going to take a long time for it to move to a place that's, I would say, like industry ready. It is a good thing to think about. It's a good thing to be aware of. Guardrails specifically, so this is Microsoft's version of this, is good for things like helping with output parsing in terms of your you know, your lang chain flows, in terms of negotiating how to deal with difficult content. So this is like potentially inappropriate content, or what you might define as harmful content, depending on your organization. But validation itself is a problem that winds up being very in-house until these systems mature. That's where I'd leave it on validation. It is good to know about, but you're going to wind up doing it a lot yourself, just by the nature of each application being unique.
Awesome. So that's about the full picture. You know, in conclusion for the day, what we learned about was visibility. And, you know, it's all about seeing in to the chains, to the systems that we're building. We can do that through WandB trace. And we saw that LangSmith has some of the same capabilities as well. And we can build some pretty dope stuff with it. There are many ways to improve our RAG systems. We are going to talk about a couple of the fun ways to do it tomorrow. We're going to build our own RAG system. We're going to present it to you guys. We will record those for anybody that cannot attend. We will do a hackathon tomorrow. So, you know, bring your best and your worst. We'll help you get where you need to go. You'll be amazed where you can go in 2 hours after this kind of training. And this is exactly the kind of thing that we want to be able to tell companies our people can do, is they can build amazing things in just a couple hours. So bring it and show us your stuff. We can't wait. I'm going to try to get 100 people in the room for Thursday. That's right, Sarah, we're going for it. because I know you guys are going to bring it and you're going to build awesome stuff. If you know exactly what you're building, DM me on Discord and tell me what it is. If you don't know what you're building, start a Cord question channel and let us help you figure it out. With that, you know what time it is. Feeback.